Alright, so we're going to go ahead and do section 6.7 quickly. And 6.7 is over graphing linear inequalities. So the first thing I want you to notice when you see these problems is that now we're going to have both an x and a y. And when we have both of an x and a y, we're no longer solving with one variable, and we're no longer going to have answer in one dimension, which was a number line where there's only one dimension. Now we have two variables, x and y. So our graphs are going to get two dimensions, so that's both an x value as well as a y value. So we have two-dimensional. In order to graph these, there are really just four steps. The first two are, well, maybe even the first three are pretty easy. Slope-intercept form, so y equals mx plus b. Identify the slope and the y-intercept. Remember, that's what m and b stand for, slope and your y-intercept. We're going to use those values to graph the line. Here's where things are a little bit different. If we have a less than or a greater than, our line should be dashed or have holes in it. If we have less than or equal to and greater than or equal to, our line should be solid or filled in. The last piece is that we're going to have to decide about that arrow, but in this case, instead of having just one arrow, since we have two dimensions, or we have surface area, we're going to be talking about shading a portion of the graph. When we look at this first problem, notice right away that we have y is less than or equal to mx plus b. So our slope, the number in front of x, is 1. Our b value is at positive 4. So remember, b is our start. So we'll start on the y-axis at positive 4. And our slope is 1. So we'll rise 1 and move right 1 to put in the next point. Now we'd like to have a couple of points, so let's work backwards to put in some more. We're ready to sketch our line. And to sketch our line, we need to first go back to that slope-intercept form. We have a less than or equal to, so this is a solid line, not a dashed line or not an open line. Use your straight edge. Make sure that you go edge to edge, no wiggle worms like I have. Now that we've got our line in there, we need to decide where the rest of the points are, or where the shaded region is the shaded region where ordered pairs work. There are two ways to do this. The first way is to test a point. Pick an easy point. Pick an easy point. So that, for me, looks like the easiest point is the point 0, 0. I want to know if I plug in 0 for x and 0 for y, do I get a true statement? So I have 0 less than or equal to 0 plus 4. Well, that says that 0 is less than or equal to positive 4, which is definitely a true statement, which means that 0, 0 is on the shaded half of my graph. So using your pencil, simply shade in lightly this half of the graph. If 0, 0 hadn't worked, then instead of shading the side that has 0, 0, we would say that 0, 0 doesn't work, so we'll try a different one. Remember, you want to try a point that's obviously in the region. and one that is not necessarily on the line. Let's work through problem 2 together. Do you have slope-intercept form? What do you need to do to get it? Correct. We need to add 2x to both sides. So that we now have y is greater than 2x minus 1. The slope of this problem is 2, and the y-intercept is at negative 1. Remember that y-intercept was our starting point, and then we use our slope. Rise to right 1. Rise to right 1. Edge to edge. Get all of your points put in. Now it's time to connect the dots. We're going to connect them with a dashed line because there's no equal to. So again, use your straight edge. It'll make this much easier to do. And your line will be much prettier than my wiggle worms. Once you have your line in, then your next step is to test where to shade. Remember that the easiest way, the tried and true, it'll always work, is to give a test point. Try that 0, 0 or even 1, 1. Whichever one is easier, right? Pick a nice, easy point that's obviously on one side of the line as compared to the other. I like the point 0, 0. So when I do that, plug in test 0, 0. I end up with negative 2 times 0 plus 0 is greater than negative 1. Well, 0 greater than negative 1, yeah, that's true. 0 is definitely bigger than negative 1, which means that my test point 0, 0 works. So my shading is up above. Again, use your pencil lightly to shade in that half. So I told you that there was a second way to do that, decide on shading. And the easiest way for me to describe that one is to tell you to, after you got your line put in, put your pencil back on the y-intercept and then read the inequality that's in slope-intercept form. Read it back to yourself. It says the y values are greater than 2x minus 1. So the y values are greater than wherever I put my line. So the y values that are bigger are going to be up. So those are the points that I shade. Let me show you again with number 1. Put my point back on my y-intercept and then read your inequality. It says y values are less than wherever I put my line. The y values that are less, that means go down, so there's where I would shade. Why don't you go ahead, take a moment, and try problems 3 and 4, and then we'll talk about problems 5 and 6. So pause it, try problems 3 and 4.